Yeah, we were just chatting now before I press record about the pros and cons of Asia, and you just said that it's an important region now because it's in focus.
Mm-hmm. Oh, absolutely. I mean, I think most of the listeners will have, or viewers would have seen the story just in the last few weeks that, they turned up archaeology in China that suggests that our story, as a species, may well have a significant component of evolutionary time spent in East Asia, particularly in what's now the modern Chinese region. If you go back a ways, of course, the idea that human beings evolved in Asia used to be the kind of mainstream consensus view. And then with some of the advances in genetic research, they came up with this kind of, the genetic Eve model. And that inferred the idea that we had evolved in Africa, most likely East Africa. The idea of a kind of an African Garden of Eden, and obviously a genetic Adam and a genetic Eve, which was obviously structured around kind of Christian ideas that were still kind of percolating, even through the scientists of the day. But if we look again at the evidence today, I don't think we would have come to that model at all, because we have skulls from China and also DNA data that indicate that a great amount of our evolutionary experience was down in East Asia. And I was just going to rewind a little bit, say that for people who aren't familiar, the very first humans that we would all recognize as humans would be Homo erectus, right, that emerges 2 million years ago. Now, the thing is, today we find that Homo erectus fossils are of equal age approximately in Eurasia and in Africa. So
hold on. But what about the cradle of humankind that's here in South Africa?
Well, the cradle of what I would call ape-like humans or human-like apes, yes. But if you really look at the current debate, there's a genuine debate on whether we should be including any of those other earlier forms as being humans. Now, that's not to say that they didn't have some kind of genetic ancestry to us, like they may have contributed some level of, it mixing with the human ancestors. We don't actually know who the ancestors of Homo erectus were. So there's a big question mark there, Jerm. So we don't know where those people were because we're not even sure who they were. What we do know is that most of the hominin-like, or, what they're calling hominins, but I would say hominin-like. Hominins is humans. So there's a question of, are these humans? They have human-like traits. But until we see Homo erectus emerge, we don't actually have anything that I think you and I and the audience, and a great many of the anthropologists, would agree on are actually humans. So Homo erectus appears at 2 million years ago, and you get some finds down in South Africa, but you also have the Dmanisi finds. It's like 5 skulls from Homo erectus found in the Georgian Republic at Dmanisi. You also have traces of Homo erectus down in, I think it's in Romania or Bulgaria around 2 million years ago. There's tool traces and stuff, not fossils. And then over in East Asia, the initial traces of hominin presence there are 2.2 million years ago with actual tools and other traces. And then at about 1.8 million years ago, you have Homo erectus fossils. So if you think about that, essentially Homo erectus appears right across the continent, across the Eurasian continent and Africa, approximately the same time. Now that's another problem for this model, because then how do we say that Homo erectus is emerging in Africa, right? Because that's not at all clear anymore. Because who are these people in China 2.2 million years ago? And if they are the ancestors of the Asian Homo erectus, well, they're present in China 2.2 million years ago. Homo erectus appears 2 million years ago. We have Homo erectus definitely in China by 1.8 million years ago. Are Homo erectus evolving in China, Jerm? There's a big question there that we can no longer with any confidence say that they're African.
Yeah, so what you're suggesting is that the out of Africa model is bunk.
Yes, I mean, we have to say that it's on very shaky ground indeed. So what we can say is there's a lot of human-like primates that are in Africa before 2 million years ago. But I'm not convinced that we should be calling any of them Homo. Put it that way, because if you look at the actual morphology of these creatures, we would not consider them human. You wouldn't walk down the street and think, that just looks like a strange guy. You would think that is a kind of ape man, a yeti or something, or a chimp-like man, or a man-like chimp. Most of them were chimp-sized. That's the other thing you got to think about, is that when we talk about these Australopithecines and these other early kinds of hominins, as being called hominins, they're basically the size of chimps with chimp-sized brains, but they have some characteristics that are more human than chimps. But I don't think either of us would consider a slightly human-like chimp as a member of the human family. So I think that the story that's been sold to the public, if they really look a bit closer, I don't think that they would agree with some of these kind of assertions at all. And I used to accept them as well. But the more you look at these other hominins, and indeed there is a debate now, should we throw out habilis? That even habilis, which is 2.3 million years old, that's not really looking very human either. And that's the closest to Homo erectus they found. And there's a debate whether it should be removed from Homo. So there really isn't anything before Homo erectus that we can say, well, that's a human. They do not look like humans, and we have to say they look more like chimps than humans. So there is and also their brains. The other thing is, if they have a chimp-sized brain, and what is probably a chimp-like structure to the brain, I can't see how we can include them as humans. I mean, I know that we want to find, where's these missing links, and how did we turn up? But I don't think we're anywhere near resolving that. I think the reality is, what we can say is, around 2 million years ago, humans evolved somewhere, either in East Asia or Africa, or across multiple regions at once, from some kind of earlier hominin who's unknown. That it may have been a habilis-like creature, it may not have been. It may have been an Australopithecine, it may not have been. Nobody knows.
But then, Bruce, where does the out of Africa theory come from? I mean, it sounds very sort of political then.
Well, I think if you go back to when it shifted from the idea of out of Asia, and again, keep in mind, because when they found the fossils down in Indonesia, we found Java man and, some of these early Homo erectus fossils, right? So that shifted the story to Southeast Asia. And for quite a while, it was accepted that these seemed to be the ancestors of humans. And then they came up with this kind of genetic model where they used modern African DNA. And again, this is something I'm not sure if the public really understand, but fully modern African DNA was sampled. So in other words, people living in the last, few decades, not ancient DNA. This DNA was used to then infer our ancestry. It was assumed that African people, right, had always been in Africa and were the remaining, you could say, descendants of these original people. And because their DNA suggested that there had been a split around 70,000 years ago, and that there was, this was the period when they think that, Eurasia was first entered by modern humans. There was inference from looking at this modern DNA that's where everyone came from. There's this split. And they also found evidence of a fairly narrow ancestry back to perhaps a single woman living about, I think it's about 200,000 to 300,000 years ago, and similarly for a man. And again, this was just inferred that they were in Africa. Now, the problem with that, Jerm, if you think about it, is human beings are not like trees. We don't just slowly grow across a distance as the forest expands. We can just walk. We can walk miles and miles. We can make small boats and sail across an ocean. So this idea that the African ancestors were always fixed in place is a really strange assumption when you start to think about it. So there's no ancient DNA involved in this. So if you had, let's say you had really ancient human fossils and you found DNA from a 200,000-year-old African, now that could help you to build a case for the idea that we all traced back to that ancestor in Africa. But we don't have that. The oldest DNA that's ever been sampled in Africa now is 20,000 years old. That's nowhere near the start of this story. Nowhere near. Right? So you've got to remember, this is all being inferred by the baseless assumption that the ancestors of these people were always in that place. So that's the first thing that people need to kind of think through, is that what I consider is almost a fraud, really, because it's been, if you talk to people about this topic, they will almost always say to you, DNA has proven that we evolved in Africa. And that is one of the most baseless claims that is popularly shared in this topic. And I think I used to sort of accept it too. I didn't understand that this was DNA from modern Africans. The other thing is that we don't have truly ancient DNA. So what you do have is fossils of these very early hominins, and again, I question mark over them, is that the majority of the early hominins, like Australopithecines and even earlier forms, are found in Africa. So if you go to the very early part of the story, you have the majority of human-like primates are spread between Africa and the Mediterranean. And they're finding some, there's some evidence down in the Mediterranean that potentially they may have even, started off there. But we know that the Miocene apes were down in the Mediterranean and southern Europe. There was a climate shift. They seem to have moved into Africa along with giraffes and hippos. And these things used to live in the Mediterranean. Right? So they crossed into Africa during a climate event. And it seems like the majority of those Miocene apes moved into Africa. Some probably stayed in Eurasia. And there's a kind of an evolutionary hub for these primates is, in that region between Africa and the Mediterranean. So if you kind of follow their journey, then yeah, you could say that they seem to be a mostly, African kind of mix of species, of primate species. So there's a kind of assumption that these are our ancestors, and that because the majority are in that region, that must be where we evolved. But at the same time, we know that apes were in Southeast Asia. Indeed, in fact, the earlier ancestors of Miocene apes were in Southeast Asia. We also know that today we're finding all kinds of evidence for hominins, in Asia from 2 million years ago and a little bit before. So this is no longer so clear. What we can say is, for example, is chimps and gorillas and stuff. Yeah, they seem to have evolved in Africa. But even that is not completely clear, though, Jerm, because we have like 2 sets of fossils from chimp ancestors. And that's kind of crazy as well, because you think about it, you think, so where's all the evidence that even the chimps really evolved just in Africa? It's because we have like 2 fossils from chimps.
Mm. So and in your book, Into Africa, you, if I remember correctly, it's been a while, but you spoke about humans being locked in Africa due to some sort of climate catastrophe. I think 70,000 years ago or something. Is that right?
Yeah. So what happened is if you can imagine, so we have these Homo erectus are global 2 million years ago, right? So we've certainly got them down in South Africa. We've got some in the the Caucasus region. We've got some in China. We don't know where they've come from. We just know that they're spreading out across the world. That eventually, we see a transition from, and it's assumed to be Homo erectus because we don't see another potential ancestor for Homo sapiens, but it's assumed this is our ancestor. Okay, so somewhere around about 1 million years ago to 800,000 years ago, there is a transition towards Homo sapiens. Now, it's not entirely clear where that's happening. It's been inferred that that's happening in Africa, but as you probably know, in the recent discoveries in China, it's looking like maybe that's happening in China. Okay, just for people to get a bit of a sort of the background of this. So you've got this transition is occurring. We know that there is also a severe bottleneck around about this time, 1 million years ago to 800,000 years ago. There's been 2 different studies giving slightly different dates. Around 1 million years ago or around 900,000 years ago, there is a contraction down to a couple of thousand people or less. Right, again, they're not quite sure where this is happening, but this precedes the transition to the first Homo sapiens. I'm going to do a little clarification there as well, because when we talk about Homo sapiens, Jerm, there's 2 different understandings here, and I want to clarify this. This is quite important because you'll see that this confusion's come up in a lot of the discussions recently. Is like, what are we talking about when we say Homo sapiens? Because most people will immediately think of modern humans, right? And they will say, well, modern humans go back perhaps 120,000 years. Some people say 200,000. Others will say 300,000, will include some finds in North Africa, right, and Morocco that we've got. But really, Homo sapiens, if we're going to talk about it in a meaningful sense, and not a vague way, because this is something anthropologists are having a lot of heated debates over. What do we mean by things like modern human? What do we mean by Homo sapiens? Because if Homo sapiens is just the wise man, well, Neanderthals, Denisovans, and us, were basically seemingly almost equally capable for most of our evolutionary history. So from around 800,000 years ago, they all were developing the large complex brains. We can see they all developed significant, really, same kind of tool technologies. They were developing wood glues, and bows and arrows, and like we've all developed in a similar kind of way. So Homo sapiens, from my perspective, and certainly not just my perspective alone, is all of these large-brained humans from around 800,000 years ago. Right, because they're all sapiens. They're all highly intelligent. They can all make these tools. They're probably all sailing. From what we can tell, they're all capable of crossing bodies of water. They're also, the other thing is, they're interbreeding with each other. So, like, are there separate species? If they recognize each other as potential sexual partners, they have children. The children are viable, can have other children, that they are able to mix, communicate in some way, share technologies, which is shown, then, Jerm, you've got to ask, are we talking about really separate species? So that isn't really the behavior of separate species. So at the genetic level, we see also that these populations, is what I would refer to them as, you can call them races, populations, subspecies, but essentially at the genetic level, which matters more, we see that they all share the chromosome 2 fusion, which happens around 800,000 years ago. They share these what's called anomalous accelerated regions. So I'll just explain this very quickly. There are areas of the non-coding DNA, which is what used to be called junk DNA. These highly conserved areas of code, which are stable in all mammals except for humans, which seem to have accelerated in their evolution around about 800,000 years ago. Now, these gave us our complex brain. These give us the recursive thinking, all sorts of stuff that are unique to sapiens, right? But those are found across Neanderthals, Denisovans, and us. So all the things that I think you and I and most people would consider fundamental to sapiens are found in Neanderthals and Denisovans. So this is one lineage, and I would put them all as Homo sapiens, and then one of the conventions is to say you can call them Homo sapiens neanderthalensis, Homo sapiens sapiens, Homo sapiens denisova, right? And that these are all just subtypes of Homo sapiens. Modern humans is a bit vague, because then you have to say, well, we're looking at the anatomy, right, and saying, okay, well, around about 200,000 years ago, our skull becomes more rounded. And so we think there's some structural changes in the brain that make us different to the remaining populations of Neanderthals and Denisovans, and that we can say, okay, it seems like there are some changes, and we know there are some genetic changes as well, that we can now say, okay, it looks like we are changing in a significant way, and these are called early modern humans. And then over the period between 120,000 to 50,000 years ago, we seem to get to the point where we are as we are today in terms of both anatomy and behavior. And also we have the behavioral revolution, so a cognitive revolution where you get the emergence of the first art that is fully representative of real animals and people. And we start drawing that kind of art, not just symbolic art, but actually representative art, people doing things. So there's some kind of cognitive change. We also become ocean mariners in Southeast Asia around 40,000, 50,000 years ago. So we can look at those points and say, okay, we have sapiens from 800,000 years ago, early kind of modern humans from around 200,000 years ago, and then what we might think of as fully modern humans from 100 to 50,000 years ago. But I will say that those last three are all a bit abstract, right? I think if we look at the genetics, which tells us much more about a real change, then that happens 800,000 years ago. And that, yes, there are some significant changes around 200 to 50,000 years ago. So I wanted to clarify that, because I know when we talk about these terms, I don't think we all really are sharing a meaning on what is a Homo sapiens, what is a modern human, right? And if we look today at modern humans, there's obviously variance in modern humans, right? So again, what is the meaning? Other than all living extant humans are modern because they all live in the modern age. But even then, as we've touched on outside this conversation, there are obviously some differences between populations as well. So, we may not get to the point where we can say there's other species, but there's definitely different, let's say, strains of humans. And again, that gets
Bruce, to why does any of this matter?
Right. Why does it matter? I think there's a couple of different ways it matters. Okay. One area is that in terms of genetics, look, we're moving into an era where, let's be honest, DNA data, genetics, these are going to well, they already are, multi-million-dollar industries based around understanding your genetics, understanding your lineages, for medical treatments, for elongating the span of your life. There's going to be, we are in a revolution. We're looking to see, for example, if you have a rare genetic profile, you may have something from, say, a Denisovan ancestor that makes you have a skill that other people don't have. You know, it could be a cognitive skill. It could be a physical ability, like, you know, living, like we've seen in the Himalayan peoples, that they can live at high altitudes. But those genes potentially... Sorry?
Look at the Asians. The Asians, they kind of lead the world in technological progress. Yeah,
I mean, there's this interest as to whether or not there's the genetic basis for higher intelligence. And I think that these are things that are being looked at very carefully now. We're starting to say, okay, it looks like, you know, if you come from population X, there's a good chance that you have this particular gene or this particular change in your non-coding DNA, and that gives you these particular differences that may be useful for gene therapies, that may be useful for therapeutics and other areas. So there is a dollar value on this topic. That's one of the things that's important. The second thing is, I think understanding yourself and other people has a value. For most of us, recognize that, in fact, that, you know, if you are to have a knowledge that helps you to, I suppose, act and compete in the world with an advantage, understanding what we mean even by humans, and, you know, what are we? How do we think? What is the evolutionary psychology? What is the evolution of our behaviors? You know, what are the life hacks that we can employ by understanding ourselves? I think that that's another area that's important. And the third one is simply the human interest, that we are driven to understand our history. That it's an area. If we look around, look at all of the huge YouTube channels that are based just on the mysteries of the past, that there is something about us that we feel driven to just understand information which not all of it has any intrinsic value. I mean, let's be honest, to know exactly who made, say, the Olmec heads, or even, you know, exactly how were the blocks lifted in the pyramid, they probably don't have great value for any of us. You know, once they were answered, I don't think they would be life-changing. Yet we do have this sense of a driven want to know, you know, what did our ancestors do? They're part of our story. You know, we want to understand our story.
But you know that a large percentage of my audience is going to switch off purely based on the fact that you're talking about evolution. Are we discussing Darwinian evolutionary theory here?
Well, parts of it. I mean, like, my view is, I guess, more nuanced. Look, you know, I think the really interesting thing about, I look at the work just slightly different to everyone else. Again, my focus, and what I think is important about the story, is in the genomic level, really. So again, most of the anthropological story and the evolutionary biology story has been about form and, like, you know, looking at the difference between, you know, Neanderthals had a big brow ridge, and, you know, they were short and squatty like trolls, and, you know, so they're like focusing on that and saying, you know, these are the species of Neanderthals, this is species like. What I found is that there are anomalies that precede the appearance of our form, and that around 800,000 years ago, there are anomalous changes in the genome that lead to the appearance of humans. And I say these are anomalous. So unlike in any other mammal that's been scientifically examined, it seems that something has happened that's different for us. And there's 2 points of interest. One is the fact that, okay, there's a glaring red flag. Why are we different? What has happened here? Considering we're the only species that goes on to be able to fly in spaceships and stuff, right? So obviously we're very different to the other animals. So when you find that there's also anomalies associated with that difference that, you know, aren't seen in the other mammals, then that also becomes very intriguing, right? Because we have a lot of stories from, you know, religious stories and also ancient cultural stories that suggest that humans were different, that there was some kind of, let's say, an intelligent intervention, whether or not from something happened. Something's different here. It looks to me that there has been a deliberate, intelligent modification of the genome in some of these Homo erectus, and that we are not talking about just a natural flow of events, that there is I'll give you a very quick overview of this. There are several types of anomalies. I mean, if you're happy, I can give you a quick overview of why I say this. Right. So when we get to around 800,000 years ago, so we've just come out of a very suspicious bottleneck. And again, so people can have look that up. They can see that there's around 900,000 years ago, humans almost went extinct. It was covered quite widely in the press. So they found that something happens where we are narrowed down to about 1,000. I think it's 1,400 people, breeding people. So obviously there's other people who are not breeding. We don't know how many old people, but the people that were capable of breeding, a very small number. And that was a drop of 99% of the population previous to that point, right? That sounds like a cataclysm, okay, on the one hand, and that's the way it's kind of being framed at the moment. So there must be some kind of lost cataclysm that we don't know about, probably an environmental disaster that wiped out these other people, and yet they can't find any evidence for that. Now, my view on that is quite different. I think that what happened is that around that time, human ancestors are down in Southeast Asia. And again, recent stories, I'm sure people have seen this idea that there was sailing to Sulawesi and to Flores over 1 million years ago. Okay, very recently, that's been, again, major news. Now, if you think about it, if our ancestors were Southeast Asians, not Africans, right, were Southeast Asians, when these groups crossed the Wallace Line, which is like a geological barrier that separated most of the mammal life from the Oceanian unique flora and fauna, right? It's mostly marsupials and their own indigenous plant species that we somehow managed to cross. So in other words, someone is building watercraft, probably just simple bamboo rafts, but they managed to get across to these islands. Well, funnily enough, it's not long after that crossing that we see this 99% drop in the human population. Well, there's one other way you can get that kind of drop without a cataclysm, and that is isolation. Like if a small splinter group of humans broke away from the major, global population, and if those people are our ancestors, that will look like a cataclysm. What you'll see is a sudden bottleneck, and that's exactly what they found, Jerm, is that there's a 99% drop not long after humans cross into these islands. So if you think about it, to me, it looks like our ancestors are these first sailors, that they have sailed across to Flores, they've sailed to Sulawesi, and then if you look on the map, everyone looks on a map, what's really close to these islands? Well, the enormous continent of Australia. If you can sail across Wallace's Line and you can sail between these islands, which have got powerful currents that take you out into the Indian Ocean, today professional sailors say they struggle getting across some of these channels because you'll be pulled southwards. But somehow these people did it, right? Then you only need to go south from these islands to hit Australia. And so there's a big question mark. When did humans reach Australia? But I think that we probably reached it not long after this. So this region of the islands of Southeast Asia, northern Australia, I would say is where our ancestors are when this change happens. And this change is quite profound. We see that around 800,000 years ago, we get the fusion of chromosome 2 that we touched on earlier. So we can see that in the genome, 2 ancestral chromosomes that are seen in our closest relatives, the primates and assumed to be in Homo erectus and other hominins, have fused together in an end-to-end telomere to telomere fusion. Now, these are very rare kinds of fusions. I mean, from what I can see, they're known in a couple of other species. They are not common because the telomeres protect the ends of your chromosomes in such a way that this really, shouldn't happen. That's kind of the point of the telomeres. So there's a direct fusion. The dating on this suggests it happens around 800,000 years ago. There's also changes to the information on this chromosome. So it looks like there's additions and deletions on the chromosome, right? And these changes also have an effect on the brain, the immune system, reproductive system. Well, that in itself is strange. We know that's at the base of the beginnings of Denisovans, Neanderthals, and us, right? That's right at the base when this split happens. We start seeing all these large-brained humans. But alongside that, you also get some really, really strange changes in the non-coding DNA. Again, we touched on earlier the idea of what used to be called junk DNA, now is known as non-coding DNA. So this is the vast majority of DNA, that most of your genome is not there coding genes. It's regulating the genome. So these regulation areas will decide, well, they'll switch on genes, switch off genes, They change the amount of expression of a gene. So, if you have an arm gene, if the expression changes, you can have longer arms, shorter arms. If the arm gene turns off, you've got no arms. So they're doing really important functions. Now, suddenly, at this same period in time, a number of extremely stable genetic regulators are suddenly massively changed. And I say this, I'll give you one example. HAR1, which was the first one of these human accelerated regions that was detected, is a short 118 DNA letter long piece of code. It was contrasted between humans, chimps, and chickens. And the chicken and the chimp have been, in terms of conventional evolutionary theory, they've been separate for 300 million years. Right? Obviously, very different species, barely related. And they found that 2 letters had changed in that time. So we've got a kind of a mutation rate there of 1 mutation per 150 million years. I mean, I think we can all agree that sounds pretty damn stable, right? And then you have a contrast between the chimps and humans. And again, in the conventional models, they've been separate for about 7 million years. So you would expect no change. A rate of 1 per 150 million years, they should be identical. Okay. Instead, what they found was 18 letters had changed. So this was totally unexpected. And in their own models, they said that basically when they put it through the biostatistical, models, and it comes up with essentially a 0% chance of this happening by any understood evolutionary mechanisms. They've now found there are several hundred, actually there's a couple of thousand or so of these that they've got to now. And these are mostly to do with the brain, particularly the development of our brain during the fetal stages. So over half of these anomalies that have been detected are to do with the fetal brain development that makes us different to all the other primates and hominins, right? Now, if we talk about random evolution, which is, again, at the base of Darwinian evolution, is the idea of random mutations and natural selection, okay? Well, this isn't random, because if first of all, if these changes are going against the evolutionary theory that they shouldn't be happening, first of all, that's not fitting the model. The second thing is that they are suddenly giving us advantages, which doesn't look very random, and that 50% of them are to do with the brain. Well, that implicitly isn't random. Random is all parts of your body changing, right? That's random. 50% or more changing your brain is not random.
So what do you think is going on, Bruce?
To me, it looks like a deliberate technological modification of the genome of the hominins living at that time. Obviously, that's a super controversial take, but yes. The only thing that we know that can really...
Wait. Hang on. Be more specific.
Right. It has to be a non-human intelligence. It has to be something that is not a human being.
God or an alien.
Right. You're left with God or aliens. Now, most of the intelligent design community today leans in towards it being God, although that's not implicitly stated, but I think you'd probably agree, and I think most people agree, that if you look at intelligent design in general, the majority of scientists in ID today are coming at it from a religious perspective, and that they usually will infer that what they're talking about is a grand creator of the universe, and they look for signs of creation throughout the universe and in life, and particularly in humans, and that they will infer that this is the handiwork of a divine creator. Now, I take issue with that, because while we can never dismiss that, because of course a being that can do absolutely anything, right? So of course you can always invoke it. But if we look at humans in particular, what we find is that there are many errors amongst these anomalies, and that we have a lot of problems as a species, particularly genetic problems, reproductive problems, problems in the development of the fetuses. We have also things the other primates just don't have. And that many of these issues are linked to the same areas that we're seeing that changed to give us the brain and to give us this unique anatomy. Now, if we're talking about a perfect engineer, the perfect creator, right, of the universe, how would that happen? Exactly. Why is he making so many errors with us? So I don't see that this is the handiwork. In the universe around me, Jerm, I see, yes, the handiwork of some supreme intelligence that's given us stars and black holes and a cosmos and, the whole background to the existence that we have. But downstream of that, there is the action of intelligent beings like us. We've modified our environments. We can do genetic engineering. We do all sorts of stuff, right? Which we can't then say that if we modify a spider to spin, metals, which we're doing stuff like this, right? We're doing that is not the handiwork of God directly. We can infer that we are doing it because God once created life, but that's not the handiwork directly. And that's the same thing I think we're seeing here. Is we're seeing what looks to me like the fingerprints of an intelligence, but not a divine intelligence, not something that can just, click its metaphorical fingers and make a perfect species. No, because there's too many errors.
Sorry, man, but it almost sounded like you were going to say the fingerprints of the gods, which is a famous title.
Well, I do have an article called like, "The Fingerprints of the Alien Genetic Engineers," because it is of that vein. That when we look at this, to me, the errors are almost as important as the upgrades. And we hear a lot about upgrades when people sort of say that they think humans were modified. Obviously whether in ID or in some of these other more fringe ideas, like the Sumerian texts suggesting that humans were modified. They talk about the Anunnaki and some of these ideas, and people talk about upgrades.
Oh, that's quite Ickean. Yeah, David Icke talks about that.
Right. Well, the thing is, I'm as interested in the errors as I am these upgrades for this reason, because if you're going to differentiate between God and a supreme creator and the actions of other non-divine or small gods, small g gods, beings that have amazing abilities and probably technologies that we can't fathom, what would differentiate their work from a divine creator? Well, I think it's the errors. So, and the funny thing is that if you look at our species, particularly the reproductive problems that women have, right, we are quite unique in that a huge number of pregnancies end in spontaneous abortion. And that is mostly to do with a self-fixing system where genetic errors in the fetus are detected by the woman's body and it spontaneously aborts them, right? So there's a huge percent of these fetuses that have genetic problems. And even with that function there, we know a lot of pregnancies end up with children that have genetic problems still, even with that. And then we have all kinds of...
That shouldn't happen if it were God.
Right, if God's doing this... And by the way, Jerm, aren't we told God's against abortion? So why is God aborting something like 20% of pregnancies?
Yeah.
Right? So to me, again, these are questions that people don't seem to like to tackle because it would make God the ultimate abortionist. What? That's not supposed to be part of the story. So something else is happening here. And we can see that this isn't seen across our closest relatives. And in fact, we also have some most difficult birthing, right, problems. Women dying in childbirth. It's not new. For ever since we've been a species, we've had these problems where either the pregnancies are a problem, the birth is a problem. We have some of the most painful birthing process of any of the primates, right? We have more genetic anomalies and problems than any of the other close relatives. And the reason why you have, and again, I'll just pause there and say, now, one of the main processes in evolution is supposed to be kind of the ridding us of problems through natural selection. So good things are preserved, bad things are got rid of. So you've got to say, well, okay, well, considering that the most important process for any organism surely is reproduction, right? Like if we just take it from a background view of evolution and life, that the most important process for the survival of any organism is it reproduces and has offspring which are successful and they can reproduce. So evolution should be working in the background to rid us of all of these problems. And it's had plenty of time. It's had at least 800,000 years, right? It's had plenty of time. So they're still there. Well, why is that? Well, it turns out that many of the gene changes and the non-coding changes as well that give us these, we can call them brain upgrades, if you like, but that give us the abilities that we have that make us unique and that allow us to have all these technologies. And also the anatomy, like thumbs and everything, these things that we have unique to us. It turns out that a lot of the same areas of the code that gave us that are causing these problems, these genetic problems. So evolution can't help us because if it was to rid us of those areas by saying, okay, those be cleared away because they're affecting evolution. Well, it can't, because our brain that's giving us the advantage is part of those same areas of code. So it's not, they're not going anywhere. The only way to address that would be, ironically, through genetic engineering, which is how they got there in the first place. That's it. Kind of, it speaks to the fact that these are not problems that nature has baked in. These are very strange changes, and the only way they can be fixed is through genetic engineering. So it's kind of pointing to how they got there in the first place, that evolution is incapable of dealing with this, because it would have to get rid of our large brains to get rid of these genetic problems.
But what's interesting, Bruce, is then you're implying that something long time ago was playing around with humanity. And does that at all play into the simulation theory that we've often heard about, or not?
Well, I'm probably unique in terms of people that, in this kind of field that spend a lot of time in the anthropological world, is to say that we have to consider, whether or not we are in some kind of simulation. And I've always found it's kind of ironic, because obviously I have debates with other, I guess, thinkers in this area. And I don't know of any anthropologists other than myself that even consider that, well, how would what we observe in the evolutionary story be impacted if we might live in a simulation? And I think these are real questions we have to ask. We say, well, could someone program in some of this stuff? What kind of simulation are we in? Are we in a technological simulation, like a really something generated in some, quantum supercomputer by some civilization? In which case, some anomalies you could simply look at as, could someone just change the settings on the simulation and therefore change us? And also, if you involve aliens, again, obviously, I'm not sure which is more controversial, Jerm, aliens or the simulation, to be honest. Obviously, they're both radical interventions into our story, right? They should radically change how we view our world, ourselves, and our evolution, how we got here, right? They have to. But when you look at, say, for example, now there's this mystery of how certain hominins got to distant islands, so they're still arguing over, did they have boats or not? Okay, fine. But if we are invoking aliens, and I don't use this as an argument generally, but they could have just picked up some hominins and put them there. So, these are things that they sound wacky to people, but if there are other intelligences operating, they can do whatever they want. They don't have to work with what seems reasonable to us. So we'll spend a long time arguing over, did someone once build a bamboo canoe, to get somewhere? But if there is another player in our solar system with crafts and technologies, and that they've been involved in experimenting with us, well, they can come down, pick up some humans, and take them to Socotra, which is where they found evidence of. It seems that humans reached Socotra maybe 2 million years ago, and as you probably know, it's off quite a trip off the coast of South Africa to the island of Socotra. And if we're saying that humans got there about 2 million years ago, which is supposed to be long before hominins had figured out watercraft, well, there's other ways that could happen. Like, if we're in a simulation, it could just be you modify the simulation and that they're there. Yeah. Or it could be, if there's aliens involved, they fly down in a craft and they take beings there. But no other real kind of anthropological thinker would invoke those. And I understand why. They don't want to be ridiculed. They don't want all the controversy that comes with saying that. But these are not unscientific ideas. They are scientific ideas, but they're just on the fringes. There's nothing in them that invokes, magic. We're not talking about like magic. We're talking about things we understand. Yes, you can simulate worlds. We're getting towards that. And yes, you can have technologies that move people around. We have helicopters. But obviously, if an advanced race had craft that can get here, then they certainly have craft that can move hominins around. And so while I don't tend to make those arguments, I keep them in the back of my mind and think, well, are there problems that we see sometimes that are so strange that the only way that you could really answer them right now is by saying some other technology, hugely further along, is at work here and is...
Bruce, does this also mean that if the out of Africa theory should be, do I say rejected or do I say shelved? But that theory argues that we all have a common ancestor. Basically, it's black people, right? The whole world. We all basically come from black people. And I think that's generally laughable for a number of reasons. Alternatively, then, is what you're talking about perhaps suggesting that there are multiple origin stories?
Well, yes. I mean, I think the multi-regional theory makes more sense, particularly if we, consider what I said earlier, that if Homo erectus is really our ancestor, which it looks like, again, that's not controversial to say, that's pretty much the mainstream view, right? And if Homo erectus is in the Caucasus, is in Southeast Asia, is in China and in Africa, then you no longer have really a leg to stand on to say, but it must be the ones in Africa that were our direct ancestor. That is not a scientific position you can hold anymore. I don't see how anyone can now, at this point, with all the evidence we have, that if you were to start fresh, right, which is I understand that's a difficult problem for anthropology because you're building on decades of teaching, learning, dogma, right? So you're not coming in with fresh eyes if you've gone through the process of becoming a mainstream anthropologist. And I don't want to disparage everyone because there are, of course, free thinkers in that. But if you were to come in fresh today, Jerm, and just look at the data available, look directly at the genetics, look directly at the fossils, at the archaeological evidence, you would have to say that, well, Homo erectus appears to be the first true human, the first real Homo. All the other ones should be booted out. Anything before 2 million years ago does not look like a member of the Homo genus. They just don't. So boot them out. So that puts Homo erectus as a global population already, and then it can be evolving, interbreeding with each other across all these regions. And at some point, Homo sapiens, but not just possibly other variants, but Homo sapiens emerged from this regionally interbreeding population, because these Homo erectus are almost certainly, they're mixing with each other across these regions. Your gene flow will be going across Eurasia and Africa because they're all essentially the same species, right? There's no particular reason other than times where they're cut off geologically, and there'll be times when populations are isolated because of climate or migration to somewhere new. But if we're talking the long term, there is sharing of genes across the region. So this is a multi-regional view. And then at some point, and I'm saying 800,000 years ago, in Southeast Asia particularly, we have a change that leads to a new lineage of Homo sapiens, which I'm putting down in Southeast Asia and Australasia, in that region, because, again, the evidence points to a migration into that region at exactly the right time to explain that population drop that they found now, which was a prediction of my model, is we should have seen a bottleneck around about 800,000 years ago, just when they found it now. And I'd also they should be down in Southeast Asia. Well, we've now found that they were sailing around down there about 1 million years ago, so they're there in the right time. So if we view this again, we'd have to say the origins of Homo sapiens are Southeast Asian and Oceanian, right? And that then this population, after it has changed, it back migrates back up into Asia. So, and we can see this, again, you can see this on the bottleneck chart. And again, if people go and look at that story of the population collapse, there is a sudden increase in the population around about 800,000 years ago. So the collapse is about 900 to 1 million years ago. And then around 800,000 years ago, there is a sudden increase. Not a gradual increase, Jerm, a sudden increase. And that is not right back to the original. It's about, I think it's about halfway back to the original size of the population before the bottleneck. But that means that they have met another group. So who are these other, if everyone was wiped out, who are they meeting? So in other words, they've gone back to Asia. There's still people in Asia. They start mixing with them again, and there's a sudden end to the bottleneck. And so this is the beginning of a migration of our real lineage back into Asia, into East Asia, where they're finding these skulls now of what they consider the ancestral population to Denisovans, right? So they're finding those in China, in East Asian region. The population then migrates through Eurasia. We get Neanderthals essentially take most of I think they take this India, most of the Middle East, and into Europe, right? And then our more direct lineage is also present. So what we consider as, I guess, very early modern human lineage. So they seem to migrate across Eurasia, with some of them entering into North Africa, right? And so we do find some of these, what they're considering now, early fossils of modern humans, but they're not modern, but they're on their way to becoming modern humans. So you've got these three subpopulations of Homo sapiens who are spreading around Eurasia, are entering Africa, and are entering Europe. Now, this is where it gets a little bit controversial and problematic, is where when we get to Africa, we've got to take into account that Africa is populated by the descendants of Homo erectus, African Homo erectus. Now, if you think about it, so if Asian Homo erectus led to Homo sapiens, and that is uniquely happening down in Southeast Asia and then East Asia, and then there's a movement into Africa, well, there is a more evolved, from our view, a more modern form of erectus, or a more modern form that has become sapiens, is now encountering the descendants of African erectus that hasn't had this event happen, that hasn't had these gene changes, hasn't had the chromosome 2 fusion. So from our view, these are more archaic. And so there is a mixing, and that has been detected, Jerm. So there's a detection that the lineage of modern humans who enters Africa mixes with the descendants of Homo erectus in Africa. And these are a much more archaic, and we'd have to call them a more, I don't know, you could go primitive or less of, whatever you want to call it. But this is an issue because actually the DNA that they're getting from these other groups is not an advantage. It's an issue. And I say this as a person who has African ancestry, that, I look at it and I think, because that is going to bring in some certain problems. The other thing it does as well, Jerm, think about this. One of the claims in this story is that but Africans have the greatest genetic diversity, therefore they must be the ancestral population. Well, there's another way you can get this diversity. Mix with another completely different lineage, because it will have, that will add an enormous amount of genetic diversity. It's not necessarily a good thing, but it will add a huge amount of diversity, and this is now being detected. So this is an Achilles heel in this story, because if you think about it, if there's another lineage that was separate for around 1.5 million years, is what they're saying. They feel that this lineage that they've mixed with has been separate for 1.5 million years. Well, the diversity you'll gain from mixing with a group that's separate is enormous, and that is exactly what we're seeing, and that has skewed this story towards Africa. And this is, I think, only now people are starting, anthropologists are starting to have to rethink this and say, well, hang on, we can explain that diversity in another way. And so I'd say to people, have a look again. And if I'm saying, check it, it's from, these are from mainstream studies. It's not something I'm sitting and, working on some other data that they don't have. It's just how you interpret the data. That's the only difference, is each person looking at it, and each scientist obviously will have a slightly different interpretation, but they're having to recognize that, we're seeing now that the remnants of Homo erectus were in Africa. And again, look at Homo naledi, Jerm. Look at Homo naledi, right? Right, well, that's not a human. That is some kind of remnant of these African Homo erectus. And look at it. Does it look like anything like a modern human? Does it help? No. It looks much closer to these chimp-like earlier hominins that were in Africa. So it's probably some blend of African Homo erectus and one of these Australopithecines or something. So you've got creatures like that in Africa. Now, if the lineage of more evolved humans from Asia is mixing with some of these things in Africa, you're going to end up with their genetics entering into that population. And that's what we do see. And so a lot of areas of this story change. Now, look, another simple thing for people. I don't want to make it too complicated. One of the key signs of evolving towards modern humans is neoteny. And I think that's pretty widely accepted. So neoteny is the retention of juvenile traits into adulthood. And so if you look at a baby chimp and you look at a young human being, they're actually quite similar in their morphology. They look quite similar. It's the adult chimp that has the brow ridges, the prognosticated jaw, and has all of the strength, and it starts to look completely different. It's super hairy, right? So it's the adulthood of the primate that makes it look super archaic, right? So what's happened with modern humans is we've retained juvenile features into adulthood. Now, if you look across all the populations of the world, it's very obvious which one has the greatest degree of neoteny. It's East Asians, hands down. They have very flat faces, very rounded heads, very little body hair, more encephalation, slightly larger brains on average. They have all of the key characteristics of being the most evolved modern human population. Now, that is a kind of, you might say that's a controversial take, but that is, again, that's based purely on the fact that we say what differentiates modern humans and humans in general from the other primates is neotenous processes more than anything else, that we have become much more like a fetal or infant stage primate over time. So then if you're going to say, like, what is a key marker of us becoming more modern? It's becoming more neotenous. So how can we say that the root population of modern humans is those that look the least neotenous? Doesn't make sense. So if we're going to look at people in Africa or elsewhere, it doesn't really make sense. It's pretty obvious that even Europeans, not quite there, more so. But you have to look. I mean, you've been to China. You've seen, look, if you think in your head, who looks the most infant-like in adulthood? Who has these flat faces? Who has these, you know, more rounded skull shapes? And who has the less body hair? It's East Asian people. And that's where the evidence is pointing to where the first modern humans were living. And in fact, the first progression into fully behavioral modern humans is happening in places like Sulawesi, where if you look on Sulawesi Island, it's got the first art that, you know, figurative art of animals and stuff in the world is on Sulawesi, not in Europe, not in Africa. You know, this behavioral revolution, they're the first people doing ocean fishing 40-odd thousand years ago. So really the blooming of fully modern humans is happening in Southeast Asia and East Asia. Like the rest of us just kind of have to suck it up. It looks like that's where it happened. Whether we have a preference to our own population or not, it seems that that's where it's happening. And that the physical evidence looking at the traits and the emergence of behavior, the breakthroughs and stuff, these initially are happening in that region, and then they are filtering out to the rest of the world. And that some populations are encountering other archaics and are mixing with them, and that they have strains from these other archaic groups. But the most modern people are really East Asians.
But then why is the African model being pushed so much?
I think there's twofold. I think that, you know, as I say, if you were to go back at the beginning of the kind of genetic revolution, I don't think that everyone was, well, there were two things. There was a religious part. It's, again, you know, think of the terminology, that they were looking for this Eden, you know. And so what they felt they found was this kind of this primitive Eden where there was this African, you know, looking at the genetic, African Eve, an African Adam, and then East Africa was this kind of seen as this perfect place for this to happen because it's not too far from a migration up into Europe, and, you know, and if they crossed into the Middle East and spanned it out again, with the Middle East being seen as a kind of an central in the religious story, you know, that this is linked to some religious ideas, but also the initial genetic studies, which, again, I think I'd call them as poorly done, because they're being done from entirely modern DNA with assumptions that these people were always in Africa, the assumption that modern human populations were there for hundreds of thousands of years, and that they hadn't come from somewhere else, or they hadn't migrated out of the, you know, out and back in. That these were all assumptions, and these are false assumptions. You can't say just because you find some modern human fossils in East Africa 200,000 years ago, that, first of all, you can't even say that's your ancestor, because you don't have any DNA from it, right? We don't even know that we're related to Omo and Herto and these skulls. We don't know that they're ancestors, right? It was assumed because there's no DNA. Now, you also don't know if those individuals didn't just walk in from the Middle East, right? There's no basis to saying that their population was resident in Africa and that all of its ancestors were in Africa. These are huge assumptions that have gone unchallenged for absolutely, you know, for years and years and years, have gone unchallenged. And if we look again at that, we can say, actually, these people could be part of a population that migrated from Asia. They walked across the continent and they come in. And I'm going to quickly just do, you know, the recent out of Africa, because, again, most people are familiar with recent out of Africa, right? The idea that 70,000 years ago, some of these modern humans who've evolved exclusively in Africa, again, have walked out into the Middle East and then have walked across down to Australia, basically all the way across the continent to Australia and then to America. And that, funnily enough, actually have reached Australia before they reach Europe. Take a quick look at a map and say that doesn't look strange to you because Europe is just round the corner. But somehow these people walk out of Africa, they get all the way to Australia before any of them reach Europe. That's weird. So there's a red flag there even just glancing at it. But the second thing is, we now know that there was a climate disaster happening 74,000 years ago, at exactly the time they tell you that this migration was happening. The Lake Toba supervolcano had exploded, that there was a cataclysm unfolding across the northern hemisphere, that the worst time to leave South Africa was 74,000 years ago. Again, this is not my words. There's experts saying that it's the worst time. You'd have to walk into a drought, an apocalyptic drought across North Africa, the Levant, and the Middle East. So you're going to leave idyllic lands in South Africa and walk into an apocalypse? No, you're not. So what's really happening here is that as this event unfolds, humans who are in Eurasia, and again, they like to call these populations in Eurasia as not relevant. So they know they were there. That modern humans were accepted to have been across Eurasia and into East Asia at least 200,000 years ago. Because we find the fossils in East Asia, Mediterranean, and Eurasia, right? So they know, but they consider these as not relevant to the story, that they didn't play any evolutionary role, okay? They just died out. But if you rethink that and say, okay, so there's modern humans living across the continent. Now there's an apocalypse, right? This volcano's gone off. Are you going to stand there and die, Jerm? Or you think you're going to start to move away from what's happening? So there's two places you can go. You can either go down into Southeast Asia, cross into the southern hemisphere there, into the Indonesian islands and Australia, where you'll be fine. You can live fine. Or if you're further west, well, you're going to get pushed west and southwest towards Africa, right? And one of the places you can cross is the Bab el-Mandab, which is a very short, as you probably know, a short crossing. The Bab el-Mandab is a short crossing. You can swim it, but I mean, with a log, paddling, or if you have simple watercraft, it's an easy crossing. And where do we see modern humans seem to... Suddenly there's a change in the modern humans in East Africa near Bab el-Mandab around 72,000 years ago, with the appearance of new art, the appearance of bows and arrows, a change in the culture, and you know what? The DNA that's been associated with the recent out of Africa spreads west and south into Africa. They said this new DNA lineage is spreading into the continent, even in their own models, Jerm. It's showing it's going inwards. And if you think about that, these are Eurasian hunter-gatherers who have been pushed west by the apocalypse. They are going one way, and they have an advantage. They have bows and arrows. And why I can say that is that, I predicted that in my book years ago. And I don't know if you saw in the last few months, they have found the first arrowheads in the world in Kazakhstan, in Eurasia, long before they appear in Africa. So these people turn up and they have the ultimate ranged weapons. The African populations may have welcomed them, we don't know, but they wouldn't have been able to stop them because they had bows and arrows and the Africans didn't. And we can see how that plays out because their DNA spreads through into Africa, west and south. This is an into Africa migration. It's clearly one from genetics, from archaeological evidence, from the climate evidence. All of the evidence is on my side for that. And you're seeing now there's a slide towards that model because it's untenable to say that this evidence isn't pointing that way. The same arrowheads are appearing in Africa 72,000 years ago that we see in Kazakhstan 80,000 years ago. So these people have them first, and they are pushed into Africa, they cross the Bab el-Mandab, and they move into Africa. So these are fundamental dogmas that are collapsing in real time.
Bruce, I'm looking at the time, and this is fascinating, but I think we should come in for a landing. Mm-hmm. Your book, your work, how can I follow it?
Yeah, so I mean, the two books are obviously available wherever online where people get books. Amazon, I guess is the main one. So if they look for my name, they'll find The Forgotten Exodus, The Inter-Africa Theory of Human Evolution, which got a nice foreword by Graham Hancock on that one as well, who helped promote that, which is really cool. And also then my second book, which is the more alien-related book. That first book has no mention of aliens in it. It's just a rewrite of the conventional story. And then Exogenesis, Hybrid Humans, which tackles the idea of an intelligent intervention. And that was got forward from Eric von Daniken, which is quite cool. I thought it's the two people for the two different topics that you could get to do forwards. They were the best I could hope for. So people look for those. Also on Twitter, I'm on there a lot. I'm on there too much, aren't I, Jerm? I think actually I spend too much time on there commenting to people and stuff and arguing, but people can definitely find me on there. I guess we all probably do. And yeah, I have a Substack and I have, YouTube interviews. If anyone looks for my name on YouTube, you can look for it under these topic names. You're under evolution, under Into Africa or Exogenesis. They'll find a lot of interviews that are about the books. So if they want to just listen to me talking on these topics, I'm sure across various channels on YouTube. Those are probably the best places. Twitter, in terms of wanting to talk to me or ask me a question, Twitter is the best place if they want to ask me any follow-ups.
Bruce Fenton, thank you for joining me in the trenches.
Thank you very much. Appreciate it.